Welcome to the Chemistry YouTube channel. Maharashtra SET exam 2020 question and answer with a detailed explanatory answer part 3. Question number 31. Boron BMe NMR spectrum of Me4 μH2B2 with nuclear spin for boron 11 is 3/2. Will exhibit quartet, doublet, triplet and quintet. Now, what is the answer here? So you see, boron has two naturally occurring nuclei. One is boron 10 and another one is boron 11. For boron 11 is 3/2, spin value is 3/2, and hence for 2Ni plus 1, you see 2 into N is 1, 3/2 is a triplet. Hence, answer C is correct. Question number 32. Which of the following is the structure of the intermediate drug, the reduction of carbon dioxide to carbonic acid in the enzyme zinc carbonic anhydrase? In carbonic anhydrase, which will be the intermediate? They are asking the intermediate. 4 options is given in this. Let us see the mechanism. Here in carbonic anhydrase, zinc 2 plus is bonded to 3 histidine residue and 1 OH minus ion, and adding carbon dioxide gives OH COO. This bond is formed, and on hydrolysis and removing HCO3 is removed to give OH2. On adding base, you will get again the compound. Now this is the intermediate, and this intermediate they are asking. Hence here HCO3, the compound containing HCO3 minus, compound containing HCO3 minus is the intermediate. Zinc bonded with HCO3 minus. Here this zinc is bonded with HCO2, and this was option A is wrong. Here zinc is bonded with HCO3, but this was not the correct form, the structure, because the OH here is on COH. COH bond is not formed as a intermediate. You should be very careful in answering this one. And here also HCO3 is present. But zinc is directly bonded with the carbon. But zinc is not directly bonded with carbon, hence this option is also wrong. So the correct option is C. Somewhat complicated question, you should be very careful with this question. Question number 33. Zinc copper superoxide dimutase is an enzyme that disproportionate. Now superoxide dimutase, SOD, superoxide dimutase is an enzyme found in all living cells. This enzyme speeds up, acts as a catalyst and speed up the biochemical reaction in the body, and this breakdown potentially harmful oxygen molecule, hence prevent damage to the tissue cells. Some superoxides, it's here you see Cu plus is oxidized to Cu2 plus, and reduction of superoxide occurs. It disproportionate hydrogen peroxide into water and oxygen. So answer B is correct. Question number 34. Trans tetraamine dichlorido cobalt 3 cation belongs to dash point group. There are 4 point group as given. Here you see in cis compound this 4 NH3, one NH3 is in axial position, another Cl is in axial position. In trans compound 2 Cl is in axial position and 4 NH3 is in equatorial position. So here they have given option D. For 4 options they have given D, but here it is a D4H. This is the correct answer. This is not a D6H, because 4 group is in equatorial, and it is not D3H is also ruled out. But D infinity H, this was not a linear, this for linear. So the point group is D4H. Question number 35. Ion is stored in protein ferritin in the form of? The answer is C. In the protein ferritin, the ion is stored in form of Fe3+. We calculate in this molecule here, the ion is 2x plus oxygen is -2. For OH it is -2, -1 into 2 is equal to 2. So 2x equal to 2 plus 4. 2x equal to 6, x equal to 3. That is Fe3+. So this option C you get it is Fe3+, and this option is correct. Here the oxidation state is Fe2+. This was ruled out, and in ferritin it was not a sulfur compound, it's also ruled out. It's not a ferric hydroxide. It was not, hence answer C is correct. Question number 36. The ground state term symbol for ytterbium Yb3+ is, atomic number of ytterbium is 70. So ytterbium 3+ is 4F13. 4F13. The Mi, this Ml is +3 for 7 orbitals, +3, +2, +1, 0, -1, -2, -3. To arrange all the electrons, 13 electrons, so that the spin is plus of 7 into plus of 7 electrons is plus of 1, 2, 3, 4, 5, 6, 7 minus 6 into, that is plus 6 into minus of, it's a 1, 2, 3, 4, 5, 6. 6 electron is minus of. So total of spin is s by 2. 2s plus 1 is 2. This multiplicity is 2. For L value, we will get L value is 3. For 3 is F state. For L value 0 means s orbital, 1 p orbital, 2 d, 3 is F. So for J equal to L plus S, this 4F13 is more than half filled, is greater than half filled. So for here you will get the term symbol F, multiplicity is 2, L plus S up to L minus S. L plus S, L is 3 plus S is plus of 7 by 2, 5 by 2, 3 by 2. We get 3 values, 3 term symbol. In this, L plus S is the ground state term symbol, that is F2 7 by 2, F2 7 by 2. F2 5 by 2 is the first excited state term symbol. This is first excited state, that's next to 7 by 2. F2 3 by 2 is the the second excited state term symbol, and this was ruled out. Question number 37. Correct order of stability of the following alkene is. In this alkene, in this carbon is a secondary carbon, this one secondary carbon, hence it is more stable, and then it's a primary carbon having plus I effect. Due to plus I effect, it is more stable than this one, and second one, this is secondary carbon and this is primary carbon. This is more stable than this one, and it is the least stable because this is also primary and this is also primary. So answer D is correct. 3 is more stable than 4. 4 is more stable than 2. 2 is more stable than 1. Correct the order of basicity of the following compound. In ammonia, the availability of lone pair of electron, that is a basicity, here is dimethylamine is more basic because nitrogen donates a lone pair of electron. Here this CH3 donates 3 electron. Here it donates 3 electron. Totally 7 electron is donated to nitrogen. Here it is 5 electrons is donated on donating a lone pair of electron. Sorry, least basic. Option C is correct. The correct IUPAC name of the following compound is. Here the compound is given. You have to number according to the alphabetical order, and here bromine, fluorine. How you have to number is, you have to number from this side. 1, 2, 3, 4, 5, 6. It's a hexane. So hexane is given in 4 options. Okay. So 2-bromo. Here, so 2-bromo is given in option C. 2-bromo, 5-fluoro, 4-methyl hexane. Option C is correct. Suppose if you take option A means it's a 2-fluoro. 2-fluoro means you have to number like this: 1, 2, 3, 4, 5, 6. 2-fluoro, 5-bromo, 3-methyl hexane. The numbering is wrong, hence option A is ruled out. Numbering is wrong, and also it was not following alphabetical order. F and B, it was not in alphabetical order. Option B is in alphabetical order, B and F, but the numbering is wrong. In compound D, you see 5-fluoro, 2-bromo, 5-methylhexane, and the compound structure itself changes. This is the 5-fluoro, 2-bromo, 5-methylhexane. So option D is also ruled out. Option C is correct answer. Question number 40. Most stable conformation of 5-hydroxy-1,3-dioxane is. Which is the most stable conformer? The OH is in axial position. Here, the OH is in equatorial position. Hence, option C and D is ruled out, because our ring flipping will not occur here. In option A and B, which will be the correct answer? Now, let us take this question is taken from Organic Chemistry by David Klein. It's a second edition, problem number 4.30. Although OH group is in axial position, the conformation is more stable if it contains an intramolecular hydrogen bonding. It forms an intramolecular hydrogen bonding here with this oxygen, and this hydrogen. 2 intramolecular hydrogen bonding is formed. So axial position, axial OH is more stable than equatorial OH. Equatorial OH does not form intramolecular hydrogen bonding. Here, see, the hydrogen bonding is formed between this. Hence, it is more stable. The more stable conformer is among A and B. A is more stable because it forms intramolecular hydrogen bonding. Question number 41. In Fisher projection, the absolute configuration of chiral center will not change from R to S when. See, in Fisher projection, your changing means that is 1, 2, 3, 4 means if you get 4 here, you have to do even number of changes. It's a 4 here and 3 here. 1, 2. Again 1 here, 2 here. Like this. You have to, and now this 1 and 3. 1 and 3 will be identical. So even number of changes gives identical structure. So priority number 1 and 2 interchange. No, this was wrong. 2 and 3 is interchange, wrong. The priority number 1 and 2 interchange, and then 3 and 4 are interchange. This is correct answer. C is the correct answer. D is wrong. Question number 42. The major product in the following reaction is. Here Br treating with the NaOH, the 2-bromo-butanoic acid reacts with the NaOH to give 2-hydroxybutanoic acid. This one. The reaction proceeds via SN1 mechanism. This SN1 mechanism is a two-step mechanism where Br is replaced by OH and the configuration not change. So option A is correct. Question number 43. The major product formed in the reaction is. Let us take the reactant. Br NHMe. Now PHLi, phenyl lithium. This bromine will be cleaved minus LiBr gives a radical here. NHMe. This I am treating with the H plus. The hydrogen adds here. We will get stabilize. So on cyclization and removing minus H plus, here the compound like this. Here it is N, Me, Ne. A compound like this. And again, here you see, let us count this A, E, C, T, E and F. The bond is formed between A and F. Here you see A, B, C, D, E and F. So this can also be written as, this is similar to the structure. Option B is correct. So here the Me is formed here. Me will come here. Question number 44. The major product formed in the following reaction. Here this CCl4 attacks is an anti-Marconics of rule. Hence you will get the product in CCl3 and Cl. Here this was ruled out because in bridgehead the chlorine will not be formed. Here in option A both are in axial. It was not also be formed. Here both are equatorial and here it is axial, it is equatorial, and option C is correct. Question number 45. The major product formed in the following reaction is Bu3SNH, tributyl tin hydride and AIBN. Here what will be the product on cyclization? In this reactant, this bromine is cleaved and this H minus HBr will get the product like this. Here this double bond shift here is a A and B. A bond is formed between these two and you will get on cyclization. You will get the product like this, and again on removing this H plus hydrogen, this free radical is stabilized and you will get the product like this. B is the correct answer. We will meet in the next video, part 4. Thank you for watching. Thank you.